Hi there. Right, I sold my early CNC milling machine, and this is the slightly bigger brother to the same machine. It's made by the same company. This has basically, I think about 2.5 inches more travel in the y-axis. I think it's 4 inches more travel in the x. Same quill movement. I think it's just shy under 6 inches, and it's the knee mill, so you can obviously move the knee a good 2 foot. At the moment she's stripped down. I found the x-axis ball screw, which I've actually cleaned up here. Stripped and cleaned, washed out now. She actually had 6 thou backlash. Now, unfortunately that's way too much. But after inspection and stripping and cleaning, pretty much the screw's fine. Just a bit of natural wear, I don't know. I did think about replacing it, but to be honest, at the moment it's so clean I can't see any like hardening material wear through, no pitting of any sort. The balls, albeit extremely small, seem to be fine. So I'm going to rebuild this one this afternoon, refill it with grease. It was full of cast iron dust. There's like a carbon deposit you tend to get off cast iron when you machine it or when you even touch it, and it's pretty much everywhere in the machine, so I'm glad I stripped it down. The y-axis, as you've got it here, you can see the pre-cleaned condition. Basically it's a very simple and easy to alter system. You basically have two recirculating nuts with a spacer in between, and then you adjust the spacer to eliminate the backlash. So pretty much you're pushing with this nut that way, and you're pushing that nut that way, and basically you eliminate the backlash there. I don't think it really needs any preload, it just needs to be close to zero. So I'm probably going to put a couple of tenths preload. I'm making a new spacer for the worn axis at the moment. That's this. Very clean, very unclean, shall I say. It needs a lot of still a lot of work. Big advantages, apart from the overall size to my other machine, is the fact that this has a 24-piece tool changer, albeit in need of a bit of disrepair, but you don't buy things cheap if they work properly. So she's stripped. Here's the bedway. You can see where the x-axis there is worn down here. There's actually about 1.5 thou step here and to either side, pretty much in all 4 corners. I got a professional bed grinder to come round the other day, and we looked at the table itself, inverted the table and put a straight edge on the bottom, and if there's any normally they will bow, because the support is kind of only about that wide, so as the overhang, this side will bow down as it overhangs that way, that side will bow down. But it's really good, so it's quite flat. But the Shizuku or Shizoko, I'm not sure how you pronounce it, is known to be quite a robust machine for such a small knee mill. But it's looking pretty good. Need a few bearings, say backlash adjustments, a lot of cleaning. This is going to be ground up next week. He's going to ground top side, back side of the dovetail on both, and then I'll probably need to break it back in with a scraper. If anybody's ever done any scraping before, this is a very crude and very old style tool. That is basically with a carbide tip. This is what makes all these marks, and pretty much you've got a dead flat surface. It's hard to keep the oil retention in there with a wiper or wipe most of the oil off, but having these indentations basically means it retains the oil a lot better, and basically it will probably last longer. You can have one surface that's completely flat, as in this, so you can have a ground surface here, just broken up, and then what it rides on will probably be scraped and broken up. Old school, new school is linear ways, but that's another story. That's not the way for a machine that's going to last, more to the fact that speed of assembly cuts down assembly and scraping, well, actually eliminates scraping completely. So, but this is what I did, or what I mastered as an apprentice. So pretty much after 20 years later, since I've been playing with this stuff, I'm actually building one myself. So pretty much soon. Oh yes, we ripped out all the controls. Yet again, this is the old control system that came with it. Very basic numeric keypad, X, Y, Z, speeds, feeds, and one line. Yes, ladies and gentlemen, one line of LCD display. That's it. So you can display the line of G code, and that's it. Now it's going to be converted yet again back to Mach 3. I've ordered a new breakout board with a smooth stepper. Runs from a USB supply now from a PC instead of a parallel port like I did the last one. And here's the old power supply from this unit. I'm still using the original motors at the moment, so I'm keeping to the original 50 volt power supply. I've put it into a new cabinet. The cabinet wasn't deep enough, so I had to stretch it. The original power supply was in the control box we've just seen over there. So now I've just put it onto the side of the machine. And then eventually this box here will house the Gecko stepper drives. I'm going to run encoders onto the motor. I've actually stripped one of the motors down already. It's not this one here, it's the one next to it. Taken the spindle shaft out and drilled an extension shaft and mounted it into the rotor stator. And eventually I'll run an encoder off of there. The encoders on Mac don't actually correct any missteps or any call for movement that didn't happen. But what they will do, they will check what they've told the motors to move, and if they haven't moved the right amount for whatever reason, it will just dead stop the machine, which is good. So if for whatever reason it steps out, I won't end up with a scrapped component. But it's quite a big machine. Oh, there we go. Hopefully it should be rebuilt in a couple of weeks. I shall put another video on of it running.